Hello guys, in this very lesson, we're going to be looking at division of modular arithmetic. In our previous lesson, we looked at addition and subtraction operation, and we looked at multiplication operation, and we also looked at the inverse operation, as inverse of numbers. So in this very lesson, we're going to be looking at how to divide various numbers under modular arithmetic. So let's quickly look at the first worked example. Right here we have 3 divided by 5 to be written in modulo 7. Now this can be quite puzzling, but it's very very simple. So we talk about 3 divided by 5. What's it going to be? 3 divided by 5 is going to give us something. We don't know what it is, but it could be anything. It could be x, it could be y, it could be whatever. So 3 over 5 is, let's say x for example. So x modulo 7. So if 3 over 5 will give us x, then we could cross multiply this. So that'll be 3 times 1 is 3, 5 times x is 5x. So that's going to be 5x equals to 3. That's modulo 7. So right here we have 5x equal to 3 modulo 7. Don't forget, you're thinking about 3 divided by 5, and x is the result is going to be. So 3 divided by 5 is going to be what modulo 7. So let's see what it's going to be. So 5x equals to 3 modulo 7. So what is x going to be? Don't forget, what we have right here is more or less like saying 5x divided by 7 equals to something. When 5x is being divided by 7, you're going to get something. We don't know what it's going to be. It could be v, it could be anything. It's going to be a given unknown. It's not yet known. So 5x divided by 7 could be p remainder 3 over 7. So instead of going that long route, you're just going to create, get the multiple of 7 out. So the 5x over 7, it's going to give us, let's say, v. There's a remainder 3 over 7. So this remainder here, v remainder 3 over 7. So that's going to be 5x over 7 equals to 7 times v is 7v plus 3. That'll be 7v plus 3 over 7. So that'll be 5x equals to 7v plus 3 just to go out. So we start assuming various values for v. So you can say v is 0. So more or less like multiples of 7. So it's all going down this route. Just since you're talking about the positive result, this 3 here is positive. It's not negative. You have to really watch out for what this is. If this is negative, then we're going to create this multiplication table. That's the multiple of 7. We're going to go down the negative axis. But since this is positive, we're going to go up the positive axis. So let's create a 7 times table. So that'll be 7 times 0. We give us 0. So 7 times 1, we give us 7. 7 times 2, give us 14. 7 times 3, give us 21. 7 times 4 will give us 28, and so on and so forth. 7 times 5 is 35, and so on. So we're going to take each of those results, we're going to take them and add them to this very 3 for us to get x. More or less like what we have here. All this bunch of results are likely results, more or less like the v here. All these are more or less like v. 0, 1, 2, 3, 4. So if 7 times 0 is 0, if we have 0 here, so 0 plus 3 will give us what? Will give us 3, so that'll be 5x equals to 3. We times this with the Bible side, with 5. So x is 3 over 5. So if x is 3 over 5, it means 5 times 3 over 5 will give us 3. So we write 3 modulo 7, that'll give us 0 minus 3, which is 3 modulo 7. So we're not going to use that, although the x could be 3 over 5. We're looking for a whole number, something definite, something that will not be up to the modulo we are talking about. So x here is 3 over 5. This is one of the major results. So let's try another stuff out. So let's try 7 out. So let's say the next multiple of 7 is 7. So 7 plus 3 is 10. So that's going to be 5x equals to 10. The Bible side with this 5. So x is 2. So that's beautiful. So x is 2. So it means 5 times 2 will give us 10. 7 and 10 is 1 remainder 3. So we've gotten what we're looking for already. So it means 3 divided by 5 is equals to 2 modulo 7. Now, the other set of digits we could use, other set of numbers, if you try out 14, 14 plus 3 is 17, 5 times 17 is 3 remainder 2. That's also fine. If you try out 21, 21 plus 3 is 24, 5 and 24 is 4 remainder 4 over 5. That's fine. If you try out 28, 28 plus 3 is 31. You can just keep trying them out. You find out that at the end of the day, you find that s is not only 2. S could be other result also. The way s is equal to 3 over 5. S could be 2s could be other result, but this is the most basic of the answers. That's very, very basic. This is a major answer we're talking about. Don't forget the value of x, I mean, must not be up to 7 or more than 7. So when 3 is being divided by 5 in modulo 7, the result is 2 modulo 7, as simple as ABC. So we could also use another approach. In our previous lesson, we looked at multiplicative inverse. So if 3 is being divided by 5, 3 is being divided by 5, what it means is that we can say 3 multiplies the multiplicative inverse of 5, 1 over 5, like this. So 3 times 1 over 5, that's a multiplicative inverse of 5, is the same as 3 over 5. So 3 times 1 over 5 equals to something. We don't know what it is. Equals to something equals to x modulo 7. So we're trying to divide. So we're going to get the multiplicative inverse of 5 in modulo 7. That's what we're going to do. So what is multiplicative inverse of 5? That's 5 times 1 over 5 will give us, let's say p, give us 1, I beg your pardon. 5 times 1 over 5 will give us 1. So this 1 over 5 here is the multiplicative inverse of 5. So don't forget that's modulo 7. So if 5 times something will give us 1, let's say 5p equals to 1 modulo 7. So what is that p going to be? So we're going to assume we're going to be using the modulo of 7 also, just like what we have here. Your first is 0, 0 plus 1 is 1. So p can be 1 over 5. Next is 7, 7 plus 1 is 8. P can be 8 over 5. Next is 14, 14 plus 1 is 15. So if 5p is equal to 15, don't forget 14 plus 1 is 15. So it means p is equals to 3. So 5 times 3 is 15. 7 and 15 is 2 remainder 1. So absolutely, so 1 modulo 7. So the multiplicative inverse of 5 in modulo 7 is 3. That's what it is. So you're going to come back to this. So it means 3 times, don't forget the p here, which is the multiplicative inverse of 5. Is what it is. So it means 3 times 3 will be written in modulo 7. That's what it means. So 3 times 3 is 9. So 9 in modulo 7. What's that going to give to us? That'll be 1 remainder 2. 2 modulo 7. The same result. The same result. We got the same thing. So you can use this approach. You could divide directly by forming an equation with it, or you could just do this using the knowledge of multiplicative inverse. Since it's 3 divided by 5, you just assume that the 5 which is the divisor becomes an inverse. You're still going to get the same result, as simple as A, B, C. So you're going to be looking at another worked example, which is the second worked example. Okay, guys, here's another worked example. We are looking at the second worked example. So right here, we have to divide minus 3 with 2. So minus 3 divided by 2 in modulo 7. But don't forget, we're going to work on it using two methods. So the first, minus 3 divided by 2, don't forget there's a negative result here. So we got to be very careful. Just minus 3 divided by 2 will give us something. We don't know what it's going to give to us. We just assume any of the knowns. So let it be v modulo 7. Say if minus 3 divided by 2 gives us v modulo 7. So this is an equation already. So we're going to cross multiply. 2 times v is 2v. Minus 3 times 1 is minus 3 in modulo 7. Now, this is an equation. Now, I would love you to observe something. If what you have here and what you have here could be reduced, if it's possible that, let's say we have 2v here and we have 6. So you could say 2 here 1, 2 here says 3. But you can't reduce this because they're already in their simplest form. So 2v equals to minus 3 in modulo 7. So how do we solve this? What's going to be the value of v? So we're going to use the same 7 we create. We're going to get a multiple of 7. 7 times 0 is 0. 7 times 1 is 7. 7 times 2, 14. It's a couple. 7 times 3, 21. 7 times 4, 28. 7 times 5 is 25, and so on and so forth. So don't forget this is subtraction. So if this is negative and stuff, this minus 3, it means whatever we get here, we're going to add it to it, but while adding is going to become subtraction also. We're going to be taking this off each of those results. So if it's 0, if 0 is our result, that's going to be 0 minus 3. That will give us minus 3. So if v is minus 3 over 2, it doesn't change the fact that we are looking for a whole number result. So that's that. So let's try out 7. So if this is 7, 7 plus minus 3 will give us 4. So let's try it out. 2v equals to 4. Divide both sides with 2. So v is equals to 2. So v is equals to 2. It means 2 times 2 is 4. So 2 times 3 is 4. 7 in 4. What's it going to give to us? 7 and 4 will give us 0, remainder 4. So 7 and 4 is 4 modulo 7. It looks quite crazy because minus 3 modulo 7 is minus 3 modulo 7. Is it 4 modulo 7? Don't forget, when we worked on the negative modulo. Minus 3 modulo 7, what is it going to be in positive format? Let's convert it to positive format. Minus 3 modulo 7, what's it going to be in positive format? Don't forget, if you say 7 times 0 is 0, 7 times minus 1 is minus 7. So we're going to pick minus 7. So minus 7 is the closest to it. So that will be 1, minus 1, remainder 4. So it means minus 3 modulo 7 is the same thing as 4 modulo 7. We're talking about the same result. So minus 3 modulo 7 is the same as 4 modulo 7. So if v is 2, it means 2 times 2 is 4. 4 to be written in modulo 7 is also 4 modulo 7. And 4 modulo 7 in negative format is the same thing as minus 3 modulo 7. So minus 3 divided by 2 will surely give us, that is going to give to us, what's it going to give to us? That will give us 2 modulo 7. As easy as ABC. So that's 2 modulo 7 as a result for minus 3 divided by 2 in modulo 7. Now we're going to use the other approach. We're going to assume that this 2, which is the denominator or divisor, you're going to get the multiplicative inverse for it. So it means minus 3 times the 1 over 2, which is the multiplicative inverse of 2. Don't forget minus 3 times 1 over 2 is minus 3 divided by 2. That will give us, what we're looking for. Let's say v modulo 7. So we're going to get the multiplicative inverse for 2. You understand? So you're going to get multiplicative inverse of 2, in modulo 7. Let's get the multiplicative inverse of 2. So what's it going to be? So it means 2 times 1 over 2 will give us 1. The multiplicative inverse of 2 is that very thing that will multiply 2 to give us 1. So 2 times 1 over 2 to give us 1 modulo 7. So this 1 over 2, don't know what it's going to be. So it could be P, it could be S, it could be whatever. Let's say 2Q equals to 1 modulo 7. 2 equal to 1 modulo 7. So you can use any of this. You can use, any of this multiple of 7. So if you use 0, 0 plus 1 is 1. 2 equal to 1. So Q is 1 over 2. So the multiplicative inverse of 2 could be 1 over 2. So we're looking for a whole number. So let's see 7. 7 plus 1 is 8. So it means 2Q equals to 8. Divide both sides. So it means the Q is 4. So if the Q is 4, it means 2 times 4 is 8. 7 and 8 is 1, remainder 1. So the multiplicative inverse of 2 in modulo 7 is 4 modulo 7. That's what it is. So there's 4 modulo 7. That's the multiplicative inverse of 2. So we're going to come back to this. That's minus 3 times 4. 1 over 2 is the multiplicative inverse of 2. And we found out that that's 4 modulo 7. So minus 3 times 4 is minus 12. So we're going to write minus 12 in modulo 7. Let's see what it's going to look like. So we have a table here, 7 times 0 is 0, 7 times minus 1 is minus 7, 7 times minus 2 is minus 14. Minus 14 is the nearest to minus 12. So what's it going to be then? It means you're going to have minus 2 remainder 2. So minus 12 in modulo 7 is right away 2 modulo 7. The same result, the same thing we got here. So minus 3 divided by 2 in modulo 7 is absolutely 2 modulo 7. So you can see that the division is also very easy. But for those that didn't see the previous lesson on multiplicative inverse, I'm very sure that you'll find it challenging to understand all what we did right here. So you have to see the previous lesson. So that is everything for division of modular arithmetic under basic operations. So right away, we're going to be going directly to our take-homes. Okay, guys, to round up all what we've learned so far on modular arithmetic basic operations under modular arithmetic, it's high time we got ourselves tested with some questions. So look at what we have right here on the board. All the questions right here cover all what we've done in our previous lessons up to the very moment. So we have the first you have to solve 5 times 6 in modulo 7. Second, minus 8 times 7 in modulo 4. The third question, get an inverse of 5 in modulo 4. The very fourth penultimate question, this 12 divided by 8 to be written in modulo 6. And the very last question, minus 10 divided by 7 in modulo 11. So for those that have seen the previous lessons, I'm very sure that we have what it takes to solve all those questions perfectly without messing any one of them up. So we've come to the end of everything on basic operations under modular arithmetic. So we're going to be looking at solutions to each of those very questions in our next set of lessons. And after that, we're going to be going to equations of modular arithmetic. And so that's all for this very lesson. If you have gained one or two things from today's lesson, please subscribe to the very channel at EduMosaic and give me a follow on Facebook at Revelation Hub and share this lesson to others to learn also. See you in the next lesson. Thanks and bye for now.